All right, topic 5 is going to go over properties of exponents. So on this first example, or this first property, it's dealing with product. We got to remember product is dealing with multiplying. So if you multiply bases that are the same, the a is your base, the m is the exponent. Then to simplify this, you just add the exponent. So I'm just going to abbreviate that. Now, if you have numbers, you still multiply numbers together. So like the 3 and the 6 is still going to get multiplied together. But then I go to the base of an x, all right? And so I take that exponent of 3 and I add it to the exponent of 2 on the x's. And I look at my base of a y to the 5th times y to the 3rd. That means I'm doing y to the 5th plus 3, okay? So when we simplify this, this becomes 18 x to the 5th power y to the 8th power. And that is our simplified answer. Now, for our power to power rule, we have to distribute the power, okay? So basically, to know if it's a power to a power, we need to see these parentheses and we need to see the exponent outside, the power outside the parentheses. And so they're showing that whenever it's power to a power, you multiply the exponents or you distribute the power. So where they're taking this b and they're putting it to each variable, that's why they have x to the b and y to the b. So in this example, I have a power, an exponent outside. This is just kind of like following PEMDAS. You do your exponents first. So I'm going to simplify this term first. Let's just get a different font here. Meaning I'm going to distribute this 4 to each exponent and even the number. Okay, so this first product, I'm not doing anything with. This first term, this negative x squared, y to the 3rd, z. I'm going to now simplify. This is saying 3 to the 4th power, but this 4 gets distributed to that 3. This is x to the 12th. Hope you can understand that. And y to the 12th, and z to the 8th. Okay? And so I'm just going to simplify that 3 to the 4th power. Okay? That's going to be 81. X to the 12th, y to the 12th, z to the 8th. Okay. I'm now taking that and I'm multiplying it to the x squared y to the 3rd z. Okay, so there's like an invisible 1 here. So this negative 1 to that 81, that's going to make it a negative 81. But now because I'm multiplying, I'm adding the exponents. So this is x to the 14th power. Now I'm adding the exponents y to the 15th power. And then z is like an exponent of 1. So z to the 9th power. And that is my final answer. Okay. So power rule first. And then here, now we're going to add the exponents. Okay. Now your negative exponent rule, this is one, it says right here, if I have a negative exponent, negative n is a reciprocal of a to n. So you have to flip and change the exponent to positive. Okay, so notice right here, this is kind of like saying if it's over 1, I'm going to flip that. So I put it to the bottom, the 1 comes to the top, and change the exponent to a positive. If it's a whole fraction, then you flip the whole fraction and change the exponent to a positive. So in an example here, because we have a power of a negative 4, I'm still going to distribute. I'm going to do the power rule first. This is 3 to the negative 4, w to the negative 16. But this x, a negative 2 times a negative 4, is going to be a positive 8 exponent. And what I'm going to do is I'm going to do the reciprocal for these two. Okay, they're both like over 1, and I'm going to flip them. So basically, I'm going to have a fraction where these now are on the bottom, and they're positive. And this is already positive, so it's on the top. So we have 3 to the 4th, w to the 16th on the bottom, and my x to the 8th is on the top of the fraction. Because if it's over 1, okay, that's just the same thing as keeping it on the top there. Now, what I'm going to do now is I'm going to change this 3 to the 4th as a number. So we have x to the 8th, 81 w to the 16th. And there's our final answer. So now we're just going to look at a couple mixture problems here. Simplify the expression using the rule. So problem like 13, we multiply the 4 and the 6, that's 24, and then we add the exponents, that's to the 4th. Okay, same scenario, multiply 3 and the 6, that's negative 18, and then we're adding the exponent. There's no x to be added here, so we keep to the 3rd. With the y's, we can add those exponents, and that's going to be to the 7th power. So this is like an invisible one, so this is a negative 5. This will be p to the 5th power. I can add those exponents. And then it was m, right? Yeah, m. M to the 8th. Okay. Now when we get here, we have to distribute those exponents. So this is negative 3 to the 10th power, x to the 30th power. And then you just gotta, this is one thing I didn't say in the example, but if you have a negative and you have a even exponent, that's going to turn into a positive. Okay. Again, we're distributing the exponent. This is 7 to the 3rd and j to the 6th power. Then we're going to simplify the 7 to the 3rd. Remember on our calculator, let me get out of this. You just put 7, raise it to the 3rd power. You use a caret above the division sign. That's 343. So we get 343 j to the 6th power. Now, we have a power rule with the fraction. We have to raise the power to the top, the numerator, and the denominator. So this is 8 to the 2nd power, x to the 4th power, because you multiply the exponents, 2 to the 2nd power, and x to the 4th power. Now, I don't know if you notice these two are the same. They're going to cancel when we simplify. X to the 2nd power is 64, and 2 to the 2nd power is 4. And then we're just simplifying that. We're just doing the 64 divided by 4, and so our answer is 16. So what I want you to do, we're just going to check your understanding with a couple problems online and to verify you understand. And then we're going to cover our last section that we did, which is what we just finished with our probability carnival.